Hello everyone, I'm Owen from Apache Doris community. I'm a PMC member of the open source project and also a co-founder of ValueDB company, which provide cloud service based on Apache Doris. Today I'm going to talk about one of the major use cases of Doris, observability. The observability system based on Apache Doris is famous for high performance, low cost, and open. I will talk about the characteristics and challenges of the observability use case. And then we will explore the architecture and technologies of the observability systems based on Doris. And at last, I will share some successful user stories from different industries. Okay. Observability system is very important. For example, for troubleshooting, it will improve the service stability and user experience. And for AI and LLM companies, it can provide full life cycle observabilities. For example, the model invocation and the search in the vector database. And for DevOps, it can help improve resource and collaboration efficiencies. So it's very important to build an efficient observability system. In the observability use case, the data is very different from the business data. First, the data volume is very large, usually the petabyte scale of data, and it will be stored for long term, such as 6 months or even years. But the value density is relatively low for the log and trees data, so it's very highly cost sensitive. And second characteristic is velocity. In this scenario, we need real-time ingestion and search. And the high pressure of millions of records per second, gigabytes per second ingestion will lead interactive search within seconds or even sub-seconds. And last one is for variety. In this use case, there are not only structured data, but also large volumes of semi-structured and unstructured data, such as JSON and text. Currently, there are some systems to deal with the observability data, the three pillars: log, trees, and metrics. Log, ELK stack is very famous. Logstash collect the logs, and Elasticsearch store the logs, and then Kibana provide the visualization for the users. And for trees, OpenTelemetry is very popular. And for metrics, Prometheus and Grafana is Metro. So what's a challenge for the observability systems? The first one and the most important one is the trade-off between performance and cost. I think users should need both performance and low cost. Yeah, there are two different kinds of architectures. The first one is inverted index architecture represented by Elasticsearch. Elasticsearch is famous for its search capability and inverted index. It can provide fast real-time search on especially the text data. But due to the actual storage for index and CPU resources that needed to build the index, the storage and ingestion cost is very high. On the other hand, there is some architecture called so-called sparse index or a low index or lightweight index, represented by Loki and ClickHouse. They do not use inverted index so they can reduce the storage and ingestion cost. But the search performance is very poor. You can you cannot search very fast, especially on large volumes of data. And the second challenge is the trade-off between performance and flexibility for semi-structured data, especially the JSON data. For JSON data, we have two options usually used. The first is ETL, and it tracks the data to structure. The second is just keep it as a JSON string or simply binary JSON. And for ETL option, the performance is very high, but it's not in fact flexible. Since if you want to add some fields or remove fields from the JSON data, you need to adjust the ETL pipeline and table structure of the storage system. It's totally not flexible. On the other hand, if you use binary JSON or string to store JSON, it's very flexible. You can store any JSON in it, and you can extract field from JSON string or binary. But the performance is not good, since you have to read the whole JSON and extract one field or the field you release from it. Even you just care about one or two fields. So the performance is poor. And the third challenge is about usability. Is the system easy to use, easy to maintain, for example, for deployment, scaling, and upgrade. And user experience is also important. In observability use case, people usually use Kibana and Grafana for visualization. And for developers, the API is very important. Is it easy to use? For example, does the system provide SQL or a specific DSL like Elasticsearch? And the last challenge is openness. For example, open source, is the system open source? And which open source license does it use? And for the cloud providers, is there any service on each cloud? And for the ecosystem, two major ecosystems for observability, ELK and OpenTelemetry. Okay, let's get into Apache Doris. You can build a high performance, low cost, and open observability system based on Apache Doris. This is a typical architecture. At the center is Doris. It can be used as a unified, efficient storage and analytics engine for both log, trace, and metrics data. The data can be connected by different connector tools, such as FileBit and Logstash in ELK system, and OpenTelemetry, FluentBit, Vector, and other tools in OpenTelemetry ecosystem. And Kafka is also supported as the data source. And on the other hand, for the visualization tools, Grafana and Kibana is supported. What's the benefits of this architecture? The first and the most important one is high performance and low cost. We compare with Elasticsearch, ClickHouse, and time series database. For log and trace data, we use the Elasticsearch official HTTP logs benchmark. Yeah, we see that the ingestion performance is 3 to 5 faster than Elasticsearch, and we are using 18% less storage space. And the query performance is 2 times faster than Elasticsearch and 3 times faster than ClickHouse. So you will save about 80% of your cost if you use Doris to replace Elasticsearch. And you can see more real industry user stories in the third section. And for the metrics data, we use the TSBS benchmark that is often used for time series database. We can see that ingestion performance is very good. It's 5 to 7 times faster than TimesSQLDB and InfluxDB. And the query performance is also very good, 2 to 6 times faster than TimesSQL and InfluxDB. One thing I'd like to mention that even Doris is not another time series database, but the optimization for ingestion, for the aggregation queries also make some benefit for the metrics use case. Okay, let's go into detail about the technologies behind the high performance of Doris. The first one I want to mention is about high performance inverted index. Elasticsearch is famous for its search performance and inverted index, and the public secret is its inverted index based on Apache Lucene. And in Doris, we also developed a high performance Lucene index in C++ language, utilizing the SIMD instructions of modern CPUs, which makes it faster than Elasticsearch. We also simplified the index structure, eliminating the unnecessary data structure for the observability use case. The second is for ingestion, high throughput ingestion optimizations. We develop group commit mechanism to batch the request to reduce I/O cost and use SIMD instructions to accelerate the ingestion of the data and index building process. And one important thing is that a noticeable overhead for high throughput ingestion in observability is background compaction. Usually in systems like Elasticsearch and ClickHouse, there will be 3 to 5 times write amplify due to background compaction. We developed a novel time series compaction algorithm, which will reach just one time write amplify in our system. It means that if you write 1 terabyte data, we will read and write 1 terabyte in the background. But in Elasticsearch, you need to read and write 3 or 5 terabytes in the background. It consumes much resources. And another important thing is about storage cost. We reduce the storage cost by 90% compared to Elasticsearch. Let's go through step by step. In Elasticsearch, the storage is redundant for row storage for range of data, the source field, and the column storage, doc value, and the inverted index. At the first step, we remove the row store and cut it down to 60% because Doris can answer any query just based on column storage. In the second step, we simplify inverted index, eliminating the unnecessary data structure, such as the structure for relevant score that is not necessary in observability. And it will drop to 50%. And after that, we use column storage and ZSGD compression. It will reduce March storage space. It will come to 20%. And after we reduce the storage footprint, another factor for cost is the unit price. So we observe that in the observability use case, many data are the hot data are queried more often, and the cold data is not frequently used. So we can store the hot data on SSD and HDD hot storage, but transfer the cold data to object storage, HDFS, and something like that, which is much cheaper. So the unit price can drop by 15%, and the overall cost will become just 10% of the Elasticsearch. Okay, after we dive into the performance technologies, let's continue to the second advantage. It's about a flexible schema with a variant data type. The variant data type can store any kind of JSON. It has three benefits. The first is adaptive JSON handling. Yeah, it can detect JSON fields and types and field name and types and store them as separated columns. But in order to avoid the mapping explosion problems like Elasticsearch, the infrequent fields will be merged into one. The second benefit is single field, multiple types. In JSON data, one single field, for example, ID, for one single field, the data type may change over time. For example, the ID is an integer at first, and then change it to string. This is allowed in variant, so it's very useful for the business changes. A third benefit is support for index. Index is fully support for variant and its subcolumns. You can create an index for the whole variant or the sum of the subcolumns of the variant field. You can even specify the index parameters such as text tokenizers. Second advantage of Doris for observability is simple and easy to use. First is easy for maintenance. You can use Cluster Manager to deploy and manage Doris clusters on your web browser. And Key-Bus operator is also supported. If you want out-of-box fully managed service, ValueDB Cloud is a good choice. Doris is also compatible with Grafana and Kibana visualization. For Grafana, Doris is compatible with MySQL. So Grafana can use MySQL data source to access Doris. And for Kibana, we developed a ES to Doris proxy to convert ES query to Doris SQL. And for developers, Doris provide very simple and easy to use API, the SQL interface. And more important, Doris is compatible with MySQL protocol. Doris even don't have its own JDBC driver. You can just use the MySQL JDBC driver, ODBC, and other language band APIs to access Doris. So it's very easy for developers. Doris is very open and embraces the ecosystem of observability. Doris is an open source object and Apache Software Foundation. And the license is Apache 2.0, which is very open for both developers and companies. And ValueDB provide multi-cloud agnostic cloud service for both for AWS, GCP, and Azure. For the ecosystems, Doris embraces the ELK system, such as Firebit and Logstash data connectors and Kibana visualization. And OpenTelemetry is also supported. So you can choose your favorite tools and ecosystem. Here are some demonstration. This is a demo from the OpenTelemetry official demo. It will observe a complex e-commerce system, which is written in different languages. The OpenTelemetry SDK for different language will connect the telemetry data and then send to OpenTelemetry connector. In the connector, a Doris exporter will save the data, log trees and metrics to Doris, and the Grafana web UI will connect to Doris and make the visualization for users. You can use Docker Compose to bring up this demo. In Grafana, you can see the example dashboard. This is for metrics. Certainly, it can be also used for logs. At the top is input box and search box. In the middle is a histogram graph, and in the bottom is the details of the logs. You can search in the search box, and you can even click on the trees link to see the related trees in this log if it's available. And of course, there is a dedicated trees panel to explore the longest trees. Okay, let's see something about Kibana. Kibana is designed for Elasticsearch, and it doesn't support extensible data source. So we build a ES2 Doris proxy. Kibana connect to this proxy, and it seems like an Elasticsearch service. And users can just use the original Kibana web pages, webs, and the proxy will transfer the Elasticsearch query to Doris SQL and transform the SQL result back to the Kibana. You can use a Kibana Discover page for all kinds of search, and you can even use Kibana to build dashboards. You can create some pie chart, bar chart, line chart, and even some map chart. I think it's very useful for the ELK stack users. And for AI observability, we have some integration to Longfuse, which is a LLM observability platform. It can trace every call to the large language model and to the vector database and more. Okay, after diving into the architecture and technology and integrations of the observability system based on Doris, I will share some real in production user stories. The first one is from an LLM company, Minimax. The new log system based on Doris has been integrated with all the business logs within Minimax, supporting petabyte scale storage, 10 gigabytes per second real-time ingestion, and second-level query latency. It's much faster than Nokia. And the second use case from iFlyTech, iFlyTech has upgraded its observability storage backend from Elasticsearch Nokia to Doris, cutting their cost by 16% and improving performance tenfold. The system uses a variant data type to store extended log and trace field. And the third user story is from advanced.ai. They migrated from OpenSearch to Doris, reducing cost by 45% and improving performance by 5 times, while simplifying the overall architecture and maintenance. And the fourth user story is from the bank. They generate 18 terabytes of logs every day, totaling over 40 petabytes. The old platform based on Elasticsearch suffered from high storage cost. So migrating to Apache Doris cut costs by 50% and speed up the queries by 2 to 4 times. The last story I want to share is from ByteDance. See that full support for the log and trace workload demonstrates that Doris meets nearly all the data ingestion performance requirements in ByteDance. The cluster has 3,000 cores, and the daily data growth is huge, 800 billion and about 500 terabytes every day. And most noticeable number is their ingestion throughput. 16 gigabytes per second on average, and 19 gigabytes per second at peak. Okay, that's what I want to talk about. So if you are interested in Doris or the observability system based on Doris, you can join to our community, subscribe to our mailing list, and join our Slack, especially the Elasticsearch to Doris channel. And you can also follow the ValueDB LinkedIn and get the latest news and technical articles about Doris. Okay, thank you.